very popular in national security agencies are also using it. And generally in a fingerprint, what is happening is there are a lot of minutiae or a lot of features that are there in the fingerprint. Throughout the life, more or less these features are more or less they are the same, they don't change. But slightly you cut your hand or your finger, you cut your finger and all, slight changes will be there. But by and large, these minutiae, or some of them even call them ridges, minutiae, features, ridges, all of them are the same. So they don't change too much. And this is an example of the types of minutiae that are there: crossovers, core, bifurcation, ridge, island, delta pore. They're just various features of the fingerprint. And I also told you that there is also some sort of classification of fingerprints. There are so many features, like I told you, bifurcation, arch, loop, island, ellipse, tented arch, spiral, rod, sweat gland. If you see your finger, you'll see all these things in your finger. But based on the prominence of these lines or these features or these ridges or these minutiae, they're all the same. The line, the feature, the minutiae, the ridge, all of them mean the same. Based on that, there is a classification into whirl is the most prominent type, one of the most prominent type, left loop and right loop, tented arch and arch. These are the prominent things. It's not so. In this fingerprint, you can see an arch. So it's primarily an arch is the main feature. There are, yes, other features also. There may be some pores, there may be some ridges, there may be some islands, but the prominent feature is the arch. Here it is a tented arch. Here it is right loop, left loop, right loop, whirl. And the Henry system of classification. According to the Henry system, loops, right loop and left loop is almost 2/3 of all fingerprints. Whirls are almost 1/3, and 1/3, and 5 to 10% are arches and tented arches. So this is the Henry system, and there is a prominence, so as to speak. Now, today we are going to see the different types of sensors that we use for fingerprints. Very commonly used fingerprints, a lot of offices, ATMs, airports, Aadhaar, election. So many uses are there. They're very widely deployed also. They're not so expensive. And there are 4 types, namely optical, silicon-based capacitive sensors, optical sensors, ultrasound sensors, and thermal sensors. So that's what we want to cover today. Obviously, the most common and the cheapest and is the optical sensor. So you put your fingerprint on the plastic plate of the optical sensor. There is a CCD or a charge coupled device that will convert that image into a digital signal, and that image of the fingerprint will be based on the features in the fingerprint. If you're a whirl or an arch or a tented arch or an island or a pore, it depends upon that. So depending upon that pattern on your finger, the ridges or the lines or the minutiae on your finger, that there is a digital signal that comes. And it is basically an image that is stored, and then the image is retrieved when you want to check. Now, as mentioned, this is cheap, is easily available, inexpensive. Generally, resolution is okay. They are proven over time, but there are some disadvantages. Somebody has put a fingerprint already, and then when you put your fingerprint, there may be an overlap between the last person's fingerprint and this person's fingerprint. And as the device becomes older and older, the wear and tear comes in. These issues will increase. It is wear and tear. And then another issue that now many people, of course, when this slide was made, it was not known about COVID. Now you know that through these optical sensors, COVID can also spread. You put your fingerprint, you're infected, other person puts the fingerprint, and obviously it gets transferred. So other types of sensors are also there. There is a silicon based sensor. A silicon based sensor, the simple logic is your finger is one side of the capacitor, the sensor is the other side of the capacitor, something like that. And you know this capacitance theory, based on when you touch there is a capacitance created, and that capacitance depends upon the features obviously because you're touching it, and that touch will have a capacitance that is converted into a digital image, an 8-bit grayscale digital image, something like this. There can be DC and AC direct current, but you put your finger on the capacitance, a capacitance is created, and that capacitance is converted into a digital image. You can have directly, or you can even have indirectly an active capacitance measurement on this thing. And this is more advantageous than fingerprint. Obviously, the COVID problem remains, yes, but the image is of higher quality. The resolution is better than optical, and silicon chips are very thin, and they may give you a better resolution. It's not expensive also, and thing. But there is an issue with respect to the durability. The durability of the silicon. Silicon also goes through wear and tear. So those issues are also there. Now coming to the better type of sensors, which are expensive but more advantageous, ultrasound and thermal sensors. Both are very easily, very good, efficiently used, high resolution, all those things aside, but they are expensive, unfortunately. And ultrasound, you are actually sending a signal, and the signal comes back. That is the idea. And the distance between based on the impedance of the fingerprint plate and air. Impedance is like a capacitance, you can say. It's more of a what should I say? I don't know how to explain, but it's more like a capacitance only. It is a force. You can say it's a force or a kind of a resistance that is there. So the ultrasound waves are transmitted, and the distance going and coming back is measured, and it all depends upon the impedance of the finger, the plate, and the air. Ultrasound has advantages that, when in both optical and silicon sensors, you put your fingerprint, there is dirt, you're cutting, and all those issues will be there. They are not there in ultrasound. The contact is less. It is more of a signal traveling and coming back. So that's more advantageous that way. It's not possible to cheat the device. You can't put a mask and put your fingerprint and so on. But the disadvantage is that the quality of the image depends to a large extent on the contact between the finger and the sensor plate, and it generally becomes heated. So you don't want to put your finger much time because it becomes hot. Finally, the thermal sensors are there, which use pyroelectric crystal kind of materials. Here what is happening is, based on the fingerprint, the finger touching, there is a difference in temperature happening. And that difference in temperature, when you put your finger, is converted into a voltage. And that voltage is the measurement, or the parameter that we use for the measurement. A thermal fingerprint sensor based on this material measures the temperature differential between the sensor pixels that are in contact with the ridges and those under the valleys that are not in contact. So advantages are, it's stable, good image, little expensive, and you cannot deceive. You cannot put a mask on your fingerprint and do that. These things are advantages, but again, the disadvantage is that the image disappears quickly, and if there is a huge difference in the temperature, sometimes it doesn't give you proper reading. So these are the types of sensors that are used, but I would think that primarily we are still using optical and silicon sensors. We don't use much of ultrasound and thermal because they are expensive, and they may be very expensive. People prefer the optical and silicon because they are inexpensive, easy to use. But of course, wear and tear is there, and you can spoof. All those things aside, people cannot afford to buy that many ultrasound or thermal sensors. So that is what I wanted to cover. And in the next class, we will see the actual process. There are two methods of matching the fingerprint that we will see in the next class. That's all from my side. The recording can be stopped. So let me start taking the attendance. So before I take